Hello everybody, welcome into another lesson. So today we are going to talk about logarithmic functions. So we're into logarithms now. Well, what is a logarithm? Well, let's take a look at this here. It's abbreviated log for logarithm. So you got this here, so that small number next to the log, that 2, that means log base 2 of 4. So this is log base 2 of 4 equals 2. Okay, so what does that mean? Well, here's how this works. That base 2, it's going to be a base 2. And then to the right side of the equal sign, that's what the base is raised to. And then that of equals 4. So that log base 2 of 4 equals 2 is the same as 2 to the second equals 4. So whenever you have a logarithm, you're going to take the base, log base 2 of 4, so that base of 2, set it to the power that's on the right side of the equal sign. That'll equal to what the base is of. So log base 2 of 4 equals 2 is the same as 2 squared equals 4. I got more examples here. Let's say log base 5 of 1/25 equals -1. All right? So you have log base 5 of 1/25 equals -1. Of 1/25, excuse me, just 1/5. I don't know where I got that. That'd be wrong. I don't know why I wrote 25ths. It's log base 5 of 1/5 equals -1. So the base is 5. So start with your base of 5. Then to the right of the equal sign, that's the power you're raising that base to. So this is the same as 5 to the -1st equals 1/5. So that would be log base 5 of 1/5 equals -1 is the same as that 5 to the -1st equals 1/5. All right, we have log base 36 of 1/6 equals -1/2. So this is log base 36 of 1/6 equals -1/2. So the base this time is 36, so that's going to be 36, and then to the right of the equal sign you have the -1/2, so this is the same as 36 to the -1/2 equals that 1/6. You could always say that. All right, you have log base 12 of 144 equals 2. So now you have log base 12 of 144 equals 2. Well, your base is 12. So this is the same as taking that 12 to the second power, setting it equal to 144. So log base 12 of 144 equals 2 is the exact same thing as 12 to the second power equals 144. Now, by now you've probably seen that you can have any base. You could take any base. What if I have log base e of e equals 1? Log base e of e equals 1. When it comes to a base of e, if you have a base of e, this is what's called a natural logarithm. Because e is the natural base, so a log with base e is called a natural logarithm. That is abbreviated as ln, meaning your base is automatically e, so ln of e equals 1. So if you see ln, that means natural log, meaning the base is e. So ln of e equals 1, that is the same as e to the first equals e. That's exactly what that means. Alright, let's say the ln of 1 equals 0. So we have the ln of 1 equals 0. The natural log of 1 equals 0. Well, if it's a natural log, that means the base is e. So this is the same as saying that e to the 0 power is equal to 1. And that would be a true statement because anything to the 0 power except for 0 itself is 1. Alright. Then let's talk about something here. Let's say you just see log. What if you just saw log of 8? It doesn't say what the base is. So here's the thing. This is what's called a common logarithm. If you have a common logarithm, that's the same as log base 10. Log base 10 of 8, right? So that's what that is. The common logarithm, if you don't see a base, is always assumed to be base 10. So that's something to keep in mind. Now, in your calculator, you'll either see log or ln. We're going to round this to 3 decimal places. So let's go ahead and take that in our calculator. So if you see log, that means it's taking base 10 of that 8 to 3 decimal places. That's about 0.903. So that's approximately equal to 0.903 is what you would get for log of 8. It's about 0.903. How about the ln of 10? So we're going to do another 3 decimal approximation. ln of 10 meaning it's a logarithm of base e. So in your calculator you should see the ln button. So push that for 10. You get about 2.303. So 2.303 is the approximation to 3 decimal places for the ln of 10. Now, how about something like the log of the square root of 2? Log of the square root of 2, what does that mean? That's assuming always that this is base 10. So 10 to whatever equals the square root of 2. So we'll just put log of square root of 2 in the calculator and we'll get our answer. You get about 0.151. So the 3 decimal approximation for the log of square root of 2 is approximately 0.151. All right. How about the ln of 6.9? So we're going to find the ln of 6.9. That means it's a logarithm with base e. That's the ln of 6.9. So let's put that in. You get approximately 1.932. So the 3 decimal approximation for the ln of 6.9 is approximately 1.932. So if you just see log without a base, remember, it's by default the common logarithm base 10. And that's what your calculator is set to. And if it's ln, it's always a log with base e. So those are things to keep in mind. Now, we can solve some basic logarithm expressions. So, what is log base 5 of 125? Well, okay. Here's the thing. This is the same as saying 5 to what power equals 125? It would be 3, right? Because 5 to the third power equals 125. So log base 5 of 125 is going to be 3. How about log base 7 of 343? So what is that value? Log base 7 of 343. So 7 to what power equals 343? That's also going to be 3. So the answer to this would be 3, because 7 to the third power equals 343. All right. Log base 8 of 1 is what? So log base 8 of 1 is what? This is the same as saying 8 to what power equals 1? Well, that would be 0, right? 8 to the 0 power equals 1. So the answer you would get would be 0, because 8 to the 0 equals 1. So you can also get exact answers sometimes. All right, how about log base 12 of 12? So we have log base 12 of 12, right? So this is saying 12 to what power equals 12? Well, that's 1. 12 to the first power equals 12. So the answer would be 1. Good one here. Log base 4 of 1/2. Log base 4 of 1/2. So this is saying 4 to what power equals 1/2? Okay, well, if we took the square root of 4, which is the same as 4 to the 1/2 power, what do you get? You get 2. If you negate that power, you would get 1/2. So this would be negative 1/2. So 4 to the negative 1/2 power would end up equaling positive 1/2. So log base 4 of 1/2 equals negative 1/2. This is why learning rational exponents was so important, because now we're into logarithms. You've got to think in terms of rational exponents to understand that roots can be written as rational exponents. Here's a good one. Log base 4 of 4 to the negative 0.38. So log base 4 of 4 to the negative 0.38. Well, 4 to the what power equals 4 to the negative 0.38? It kind of gives it away. It's just going to be the negative 0.38 power. Or just negative 0.38, because if you take 4 to the negative 0.38 power, that would equal 4 to the negative 0.38 power. So that one was actually pretty easy. I think we get that these are logarithms now. So this is different. Log base 1/5 of 25. This one will make you think a minute. So we have log base 1/5 of 25. So 1/5 to what power equals 25? Well, here's the thing. 1/5 to the first power is what? That's 1/5. 1/5 to the second power is 1/25. But if I negate that power, it turns it into the reciprocal. So if I take 1/5 to the negative second power, I'll get 25. So the answer to this would actually be -2. So 1/5 to the negative second power would equal 25. So there is that. Now let's talk about another fact here. So we've talked about exponential functions already, and now we're talking about logarithmic functions. Well, it turns out that logarithmic and exponential functions are inverses of each other. So let's say you have log base 5 of x, right? We don't know what x is, but you can isolate x. If you have a logarithmic equation, if you take that base of 5 and raise it to the log 5 base x power, right? So I've taken that base of 5, raised it to the log base 5 of x power, the log cancels out, and you're just literally left with the what it's the base of, which would be x. So logarithmic and exponential functions are in fact inverses of each other. And you could have a similar one here if you have log base 9 of x. So the base is 9. If you take 9 and raise it to this power of log base 9 of x, the log will cancel out. You'll just be left with x. So yes, exponential and logarithmic functions are in fact inverses of each other. Of course, I could have the ln of x. If I have the ln of x, how would I get rid of that natural log? Well, a natural log is a logarithm of base e, right? So if I take that base e, raise it to the ln of x power, that cancels out the natural log, you would just be left with x. So let's do a few more exercises here finding inverse functions. Now let's say you have y equals log base 9 of x. Since exponential and logarithmic functions are inverses of each other, we can find the inverse. So, of course, we have y equals log base 9 of x. That means to find the inverse, we got to swap places with x and y. So this would turn into x equals log base 9 of y. Well, we need to solve for y in order to find the inverse, right? So on the right side, you're going to take that log base 9 of y. You got to raise 9 to that log base 9 of y power. But what you do to one side, you have to do to the other. So that means you got to raise 9 to the x power on the right-hand side. So now on the left, the logs cancel out. You literally get that y equals 9 to the x power. So in other words, the inverse function, f inverse of x, would be 9 to the x. So exponential and logarithmic functions are inverses of each other. And when we go into graphing them in the next lesson, you're going to see how that works, because the next lesson's graphing logarithmic functions. Alright, so we have y equals log base 1/4 of x. So y equals log base 1/4 of x. Okay, so let's find the inverse function. We switch places with x and y, so x would equal log base 1/4 of y. Okay, so what does this mean? Well, we got to take 1/4 to the power of both sides, so take 1/4 to the log of 1/4 y. But what you do to one side, you got to do to the other. You're going to take that 1/4 to the x power. Now you have the 1/4 raised to the log 1/4 of y. That means the log cancels out. You got y equals 1/4 to the x, which would be the same as 4 to the negative x. So your inverse function would end up being, you could write it as f inverse of x equals either 1/4 to the x power or 4 to the negative x power. You can write it either way. That would be the inverse function, which would be 1/4 to the x, or the same as 4 to the negative x power. All right, y equals log base 7 of 49 to the x. All right, so y equals log base 7 of 49 to the x. Why don't we simplify this a little bit first before we go swapping places? So what is 49? So in fact, yes, what is 49? Well, 49 is the same as 7 squared, right? So y would equal log base 7 of 7 squared to the x, which would then have to mean that this y equals log base 7 of 7 to the 2x. Well, what is 7 to the what power equals 2x? 7 to the 2x. 7 to what power equals 7 to the 2x? That would just be 2x, right? So y would end up equaling 2x. Now we simply just switch places. You would actually end up getting x equals 2y, which means y would equal 1/2 x. So f inverse of x would actually equal 1/2 x. Sometimes you won't always get an exponential inverse. You'll get a linear or another type of inverse. All right, let's say we have y equals the ln of 6x. Y equals the ln of 6x. Well, let's go ahead here then swap places with x and y. That means x equals the ln of 6y. Now, what's an ln? That's the same as a log base e, right? That means we got to take e to the power of both sides and solve for y. So if I take e to the ln of 6y, I'm going to set that equal to e to the power of x. Well, that means on the left side that the log will cancel out. You'll literally have 6y equals e to the x, which then means that y equals e to the x over 6. So your inverse function would be f inverse of x equals e to the x over 6. That is your inverse function, e to the x over 6. I have 3 more. Y equals the ln of the quantity of x minus 1. Okay, so y equals ln of the quantity of x minus 1. Well, let's solve for the inverse. So switch places with x and y, so x would be equal to the ln of y minus 1, right? Now, we want to solve for y. That ln means you have a base of e, so you got to take e to the power both sides. So you would take e to the ln of y minus 1, set that equal to e to the x. Well, that e to the ln cancels out the log. You just get y minus 1 equals e to the x, which would give you that y equals e to the x plus 1. So your inverse function, f inverse of x, would equal e to the x plus 1. Got 2 more. All right. Y equals the ln of 3x minus 2. So we have y equals the ln of 3x minus 2. Well, in order to solve for the inverse, again, let's switch places with x and y. So x would equal the ln of 3y minus 2. Well, we want to solve for y. That ln means it's a log of base e. So we got to take e to the power of both sides. So e to the ln of 3y minus 2 power would end up equaling e to the x. Well, the e to the ln cancels out the log. So you get 3y minus 2 equals e to the x, which means 3y equals e to the x plus 2. So y would equal 1/3 of e to the x plus 2. So your f inverse of x would equal 1/3 of e to the x plus 2. That is your inverse function. F inverse of x equals 1/3 of e to the x plus 2. And 1 more. Y equals the ln of 1/4 x minus 5. Alright, so we got y equals the ln of 1/4 x minus 5. Let's solve for the inverse. So switch places with x and y. X would equal the ln of 1/4 y minus 5, right? Well, we want to solve for y. You have an ln, which means it's a log with base e. So in order to cancel out the log and solve for y, you have to raise both. You have to take e to the power both sides. So e to the ln of 1/4 y minus 5 would equal e to the x. So the left side, the log cancels out. You now have 1/4 y minus 5 would equal e to the x, which would give you that 1/4 y equals e to the x plus 5, which would then give you that y equals 4e to the x plus 20. So f inverse of x would equal 4e to the x plus 20. And that is your inverse function. F inverse of x equals 4e to the x plus 20. So now we've seen what logarithmic functions are, how they work, how you evaluate them in a calculator, and how to find the inverse of a logarithmic function. Next lesson, we're going to graph logarithmic functions, and we're going to explain the inverse relationship in the graph and in their domain and range. So I hope everyone has a good day. Take care.